1997, 1998, this El Nino, one of the reasons it caught us by surprise is because our climatological models missed El Nino completely. What the El Nino was all about was a complete breakdown in 180-degree reversal of water currents and the winds associated with those currents in the oceans of the world. We haven't seen anything quite like this before, wreaking havoc on a global level. In the deserts of Chile, for example, in South America, these are the dry, arid deserts. They received over 12 inches of rain in areas that don't normally have rain at all. We saw snow in Guadalajara, Mexico. It was the first time snow was there since 1881. Canada suffered the worst ice storm in history. Thousands of people were without power for weeks on end. Floods killed even more thousands in Africa. And in Peru, there was so much rain in the Peruvian Andes that a new lake was formed. It's a new landform now, 2,300 square miles in area. There's a new lake. The president of Peru actually took a jet ski out onto the lake and was showing that it's viable as a tourist attraction now. In Peru, we've never seen this before. Wildfires in Florida. Over 2,000 outbreaks in a 60-day period, burning 500,000 acres and losing approximately $250 million of homes and crops. That's from the most recent El Nino. Since January of 1997, over 16,000 people have lost their lives worldwide and $50 billion in damage. 456 of those lives were in the United States. What's happening with the weather? Why is this happening right now? Late 1980s, early 1990s, nearly every major publication in the West either devoted an entire issue or a special section of a regular issue of their publication to the unprecedented kinds of phenomena that we're seeing now. The breakdown in the ozone, the global changes in weather, global heating, global cooling, changes in the ocean currents, what's happening in our environment. In June and July of 1998, this was also documented in the tech journals. At least 2 major ice shelves in Antarctica have fractured. One of them is the size of the state of Texas. And if it continues to break, melt and break, we may see that massive piece of ice fall off into the ocean. And the fissure is continuing inland. And there's a second, the Larsen ice shelf. Now, researchers are watching very closely. Bodies of ice this large falling into the ocean have the potential of a profound effect on sea level. And the same thing is happening now in the north polar regions as well. Recent studies have shown that the ice melt is happening underneath the water level at rates up to 30% greater than we ever measured above. So something clearly is happening here. In 1992, we identified 20 potentially life-threatening viruses in our world that were not here 30 years ago. Why are they here now? And what do they offer to us? All of these things are happening now at the same time. The magnetic fields of our Earth, very, very controversial, and we're just now beginning to hear about this in newspapers and magazines because there's a phenomenon that occurred, and I'm surprised that this didn't make front page on every newspaper in the world. The magnetic North Pole has shifted over 10 degrees from where it was 50 years ago. This is very significant. Where we're really seeing the effects of this is in GPS, global positioning satellites, and in the aircraft industry, because our pilots navigate following these magnetic lines. There are contour maps of magnetics of the Earth. They're released, the FAA mandated they come out every 56 days. And now the magnetics are changing so quickly that they're coming out every 30 days. When you approach a runway and you see the numbers on the runway markers, those numbers are compass headings for the pilots to navigate according to. And the FAA has a mandate that says, should those numbers ever be off more than 10 degrees, we have to renumber our runways. And in 1997, the Minneapolis-St. Paul Airport was the first one to actually go and renumber the runways to compensate for the shift in Earth's magnetic north. Why is this happening now? Now, to Western science, these events I'm sharing, and many more, are mysteries with no framework and no context. They appear to be discrete, non-related events that just happen to be occurring at the same time. In the Eastern traditions, and many of the ancient traditions, these events fall within a framework of precisely what we would expect to see at this time in history and lead us to a very startling conclusion about what this time in history may offer to us. Now, I'll say this now, and I'll say this again as we go through our program. It's important to share with you that I'm an optimist, and I firmly believe that the events that we're witnessing at this time in history are healthy, natural portions of a process, a cyclic process that is rare by any standards. It's so rare that we don't have a record of it in our conscious memory. We don't have anything to compare it to. Because we've never seen it before, we don't always know what these processes mean. And they are leading us to this rare, precious, wonderful opportunity to redefine our role in this world and what this world means to us and how we relate to one another at this time in history. So as we approach this time that the ancients called the shift of the ages, we're invited to redefine what each of these phenomenon and many more mean in our lives and allow for the possibility that perhaps something rare and wonderful is about to occur in our world. And the ancients invite us to remember that the changes also happen within our bodies. And maybe that is what the people of the world feel as we journey into the villages of Peru and along the Nile and throughout the desert Southwest when they say something big is about to happen. Maybe it's that shift that they're feeling from deep inside. Well, our own science, within the last few years, they're faced with the same possibilities, and they are searching for a way to describe these changes in our own language that we call Western science. And perhaps one of the first places where these changes have been documented, digitally measured over the last few years, is in the magnetic fields of the Earth. We'll go back to the basics, back to the magnetic parameters of our planet. And I'll begin by simply asking you to imagine your mind, if you will. If you go to any hardware store in any city and take a bar of iron and you wrap a conductor around that bar of iron, copper wire for example, and you pass electricity through that copper wire, suddenly the bar becomes magnetized. It has a north and a south pole just because the electrons flowed through the wire, creating the north and the south. It's the passing of the electrons in a circular motion around fixed iron is what creates this phenomenon that we call polarity. If we take the same configuration and we simply reverse the flow of the electricity, if we pump electricity in from the other end of the copper wire, something very interesting happens. The iron still remains magnetized. The poles, however, reverse. What used to become north becomes south, and what used to be south then becomes north, just because the electricity was flowing, again, in a circular direction, this time in the opposite direction. Now, this is very important. This is basic physics. We've probably all had this in high school or college at some time. It's a very beautiful analogy for the way that researchers now believe our Earth functions. When we view a cross-section of the Earth, we see layers. Some are thicker, some are thinner. The outer crust is relatively thin. Then we have a mantle about 1,800 miles thick and what's called an outer core and an inner core. New research now is bearing out what the ancients in their texts suggested, that these layers actually rotate one inside another, inside another, inside another. In other words, the mantle of our Earth actually is moving underneath the crust. And the outer core is actually moving inside the mantle. They're all moving in the same direction. They're moving at different speeds. And they're all moving around an iron core. And this is where our bar magnet analogy comes in. As the outer layers are moving in a circular fashion around the inner core of fixed iron, that is analogous to electricity moving in a circular fashion around the fixed bar of iron. And as those bodies move, again, in the same direction at different speeds, they are creating the magnetic fields of our Earth. Now, one of the things that researchers began to see back in the 1960s, Stanford University was a pioneer. There's a gentleman named Alan Cox at Stanford University, a man way ahead of his time, a brilliant geologist. Unfortunately, he is no longer with us. And he began to notice that Earth's magnetics are decreasing very quickly. He plotted the magnetics based on paleomagnetic data from seafloor samples. We were able to determine the orientation of magnetics and the intensity of magnetics in our past. And Alan Cox began to see that over time these magnetic fields are dropping very quickly, and that in recent times they began to drop even faster. There was a rapid decline occurring in the mid-1960s of Earth magnetic fields. Well, this is interesting. If those fields are the result of cores within cores within cores all rotating, and the fields are declining, what it indicates is that these inner cores must be slowing in the way that they rotate. And now in August 1998, this is the first time now that researchers, and they were Japanese researchers, have actually published the data suggesting that's precisely what's happening. That the inner layers and the mantle of our Earth, while they are rotating, their rotation is slowing, and that's allowing a decrease in the magnetic fields of our world. Well, from Alan Cox's data and now subsequent data and years after, what we see is the magnetic fields of the Earth reached a peak about 2,000 years ago. They were the strongest that we have known them in recent history, 2,000 years ago, and for the last 2,000 years, they have continuously declined. We measure these fields in terms of Gauss, G-A-U-S-S. In the early 1900s, the composite magnetics of the Earth were measured at about 4 Gauss. Now in 1998, July of 1998, some researchers are reporting measurements as low as 0.4 Gauss. The magnetic fields are declining very quickly. This has a direct impact, our magnetic fields, a direct impact on our sleep patterns, on our immune system, the way our cells regenerate in our bodies. The ancients were very clear of this phenomenon, and they shared it with us in the only words that they knew, the words of their time. They suggested that these changes would occur. Now our own geologic history says that there's a precedent. Earth has gone through a change like this before. Earth has gone through times in its past where the magnetic fields weaken, become less and less and less, and they drop all the way to zero. Zero magnetics for a brief period of time, and they begin to increase once again. In the geologic record, we can see at least 14 times in the last 4.5 million years where the magnetic fields of the Earth have flip-flopped back and forth, sometimes for periods of time over 1 million years, sometimes for periods of time that are only a few hundred years. And it appears the last time this happened was about 10,000 years ago, which is relatively recent. It coincides very nicely with the melting of the last ice age. We can actually measure that phenomenon. So we do have a precedent for changes in the magnetic fields of the Earth, as these magnetic fields are driven by the rotation of these inner cores. What we see in geologic history is that sometimes the fields will decrease, they'll drop all the way to zero, and then they begin to increase once again, and North and South Pole remain the same. Sometimes they decline to zero, and then they stop. The North and the South Pole reverses, and the magnetic fields begin once again. That reversal now, researchers believe, is due to a reversal of the rotation of the cores from inside the Earth. As the mantle begins to rotate in another direction, in the outer core, in the inner core, these inner cores are actually in motion, and that motion is changing.